These questions are on circle theorem. Let's look at question 1. ABD are points on the circumference of a circle, center O. BOD is the diameter of the circle. BC and AC are tangents to circle. Angle OCB is 34. Work out the size of the angle DOA. So DOA is this. This is what we are going to work out. To work out that, we need to work out this angle. So before we start to do anything, we just mark all the information that is given. So BC and AC are tangents to the circle. These are equal because tangents drawn to a point, from a point to the circle, they are always equal. This is a radius, this is a radius, they are equal. Tangent meets the radius at 90. Now if you look at these two triangles here, this triangle and this triangle, they are similar because their sides are equal. These two sides are equal, these two sides are equal, and this line is common. Therefore, this angle will be equal to this angle, which is 34. Now we know this angle is 68. We know this is 90. We know this is 90. So we can find this. So let's start writing. AC is equal to BC. Tangents drawn from a point. OA is equal to OB, radius. So both triangles, write it down, both triangles AOC and CBO are similar. Therefore, angle ACO is 34. Right, now we are going to take the quadrilateral in quadrilateral AOBC, angle set up to 360. So we are going to write it. So we're going to say angle AOB, that is this, plus 90, plus another 90, plus 68 is 360 because quadrilateral angle set up to 360. So we can find the angle AOB. AOB is 360, take away all of that, which is 90 plus 90 is 180, 180 and 248. So that gives us 112. So we know now AOB is 112, so we can find AOD. Because angle in a straight line. So angle AOD is 180 minus 112, which is 68. So that's that. Let's look at question 2. Question 2. AB are points on a circle, center O. BC is the tangent to the circle. AOC is a straight line. Angle ABO is ABO. So let's connect that, join that. So that is X. This is radius, this is radius. So this is X because it's an isosceles triangle. Radius meets the tangent at 90. Now if you take the big triangle, we know this angle, all of it. We know this angle, we can find that. That's what the question is asking, ACB. What is this? So angle in a triangle is 180 and we want to give the answer in terms of X. So let's write it. So angle BAO is X because AO is equal to BO, radius. So therefore it is a isosceles triangle. angle OBC is 90, tangent meets the radius. At 90. So therefore now we take the triangle in triangle ABC. All the angles add up to 180. So x, that is that, plus x plus 90 plus AOC, angle AOC is 180. So 2x plus 90 plus angle AOC is 180. We could bring these to the other side, make sure the sign changes. So angle AOC is equal to 180 minus 90 minus 2x. So that gives 90 minus 2x. Let's do question 3. PQRS is a regular pentagon. RUT are points on a circle center O. QR and PT are tangent to the circle. So you could see they are joining the circle, so they are tangent. RS uses straight line. Prove ST is equal to UT. So ST is this, UT is this. We need to prove if they are equal, we need to prove this angle is equal to this angle. We need to prove that. So to prove that, we need to find this angle. Then we need to find this angle, then we can we have to work out that. So to start with, what we will do is we'll try and find this angle. It's a regular pentagon. If it's a regular pentagon, all sides are equal, and you can work out the internal angles of a regular pentagon. Internal angles of a pentagon, then we will find the each angle. That is n minus 2 times 180, 5 minus 2, 5-sided, 180, which is 3 times 180 is 540. So each angle will be, because it's regular, angles are the same, each internal angle would be 540 divided by 5, which is 108. So that is 108. If that is 108, this is a straight line, we know this is 72. So therefore we know RST is 108. Therefore TSU is 180 minus 108, which is 72. So we worked out one angle. Now we are going to work out this angle. To work out this angle, what we are going to do, there's a reason for us to give us, this is the center, so we're going to join that. We're going to join these two lines. So these are the radius, they are equal, but this is 90, radius meets the tangent at 90, that is 90 as well. We know this is 108, we worked out here. This is 108. So in a pentagon, we know four angles. We know that, we know that, we know that, we know that. So we can find that because angle in a pentagon is 540. So how do we find ROT? Angle ROT will be 540. Take away all the internal angles add up together. That become 540 minus 396. That gives us 144. So if that is 144, you could see now this is the arc. This arc makes an angle at the center, and the same arc is making an angle at the circumference. If you look at the lines, right? So we worked out is 144. That means this is 72. This looks like this. Just draw that. This is center. Then we have this angle here. So you could see that is 72. This is 144. Right? Look at that picture. So therefore, we could say angle SUT is half of 144, which is 72. So we know that is 72, that is 72. Therefore, it's an isosceles triangle. Therefore, you could say ST is equal to UT. Let's go to the next question. Question 4. ABCD are points on a circle. Center of BC is equal to CD. Angle BCD is 130. Write down the angle of BAD. So this is cyclic quadrilateral. Cyclic quadrilateral, opposite angles add up to 180. Therefore, BAD 180 minus 130, which is 50. So because ABCD is a cyclic quadrilateral, opposite angles add up to 180. Work out the size of ODC. We're going to work out the size of ODC. This is what we need. We know if this angle is 50, this angle must be 100, because angle at the center is twice the size of the angle made by the same arc at the circumference. So this is 100. Now if you take BODC, we know this is equal to this because it's radius. We know this is this. Therefore, this angle is equal to this angle. This is equal to this. So we can find that because quadrilateral is 360. So let's look at that. First thing we need to say is angle BOD is 2 times 50, which is 100. Then we have to say the reason. Angle at the center is twice the size of the angle at the circumference when it's made by one arc. Now if you take in the quadrilateral, OBCD, we know OB is equal to OD, radius. BC is equal to CD, given. Therefore, we could say angle OBC is equal to ODC, which is equal to 360 take away 100 plus 130 divided by 2. So that's 230, that's 130 divided by 2, which is 65. Let's look at the next question. Question 5. PQT are points of the circumference of a circle. Center O. The line ATB is the tangent at T to the circle. PQ is T. Angle ATP is 58. If this is 58, we can say this is 58. Alternate segment theorem. We also know this is 90, so we can find this. If this is 58, we can find that. This is equal to this. So we can find this. So let's go one by one. So first thing we're going to say, angle ATO is 90. So tangent means radius. angle PTO will be 90 minus 58, which is 32. So we know now this is 32. Then we can, this is a PQR is an isosceles triangle. So angle QPT is equal to angle QTP, which is 180 minus 58 divided by 2, because the reason is it's an PQR is an triangle, PQR is an isosceles triangle. So that is 122 divided by 2, which is 61. So we know this is 61, this is 61, this is 61, we know this is 32. Therefore, angle OTQ would be angle PTQ minus PTO, which is 61 take away 32, which is 29. Let's go to the next one. Points A, B, C are on the circumference of the circle O represents the center. Angle AOB is 2x plus 38. Angle ADB is 3x minus 70. Calculate the value of x. So what do we know here is, if this is 2x plus 28, this will be half of that. So we can work out that will be x plus 14. Then we know the opposite angles add up to 180. So let's write that. Angle ACB is equal to half of 2x plus 28, because angle at the center is twice the size of the angle at the circumference. Right, so we can simplify that. We take 2 out, x plus 14 is factorizing, right? So 2 and 2 get cancelled, so it's x plus 14. So we know that angle. Now ACDB is a quadrilateral. ACBD is a cyclic quadrilateral. Therefore, opposite angles add up to 180. So this plus this is 180. X plus 14 plus 3x minus 70 is 180. So that's 4x minus 56 is 180. So 4x is, bring the 56 to the other side, 180 plus 56, that will be 236. Therefore, x is 236 divided by 4, which is 59. That's the end.